Okay, we're going to refer to this as Geometry Test 1 through 35, Part 2, year 2021. Let's get our actual test pulled up. I know it's weird. Okay, let's see, question 16. All right, I know that I covered 28 with the other class, so we don't need to cover that. That'll be in the first video. Let's see, let's come up to question 16 and see if that's one that's been covered. Okay, no. Question 16 says the area of a rectangular photograph is 84 square inches. The photograph's length is 2x plus 12. The photograph's width is 7x inches. Find the dimensions of the photograph. Provide a justification for each step. The justification for each step might be a little bit much, but I would start by drawing a picture of said rectangle. It says that the length is 2x plus 2. The width is 7x. The area is 84. So how do I set this up? How do I solve for x? Equal it to 84? Yeah, we're going to set it equal to 84, but how? Why? What? What is 84 for us? Area of a rectangle. How do I find the area of a rectangle? Base times height or length times width. So if I was going to set this up in a two-column proof, and I'm not here, but I would start by, I would start with stating that this is a rectangle. That's a given, okay? The next thing I would include is area equals length times width, definition of the area of a rectangle. The next step would be to do 84 equals 2x plus 2 times 7x. That step would be referred to as substitution, right? The next thing I would do is I would distribute the 7x to each of these two terms, right? All right, so what's 7x times 2x? So 14x squared, and then what, plus 14x? And that's set equal to 84. All right, what I should see here is that I have a quadratic equation, or the beginnings of a quadratic equation. It's not in quadratic form because the 84 is on the other side of the equal sign. For me to have a quadratic equation, what does it have to be equal to? It has to be equal to 0. So for that, I need to move the 84 over. How do I move it? All right, so we would call that the subtraction property of equality. Okay? So for sake of space and time, I'm going to go ahead and I'm going to erase some things. I'm going to write back in this space so we're not going back and forth between pages. Okay? But we're going to rewrite this as 14x squared plus 14, or sorry, yeah, plus 14x minus 84. That's equal to 0. Okay, so we're just moving that up. Okay. Is there anything I can take out of every single term to make it maybe a little bit easier? Does 14 go into 84 evenly? That would be the first question I'd want to ask. It does. Okay. So that means I can divide all of these terms by 14, right? That's going to give me x squared plus x. How many times does 14 go into 84? 6 times. Okay. All right. Now that's all equal to 0. So that's just, simply division. It's not even division property of equality because I'm not doing it on both sides of an equal sign. Okay, but here I would factor. So that's going to be x and x. What are my operations inside? If it's plus minus up here, what's it going to be inside my factors? Plus minus, good. All right. Things that multiply to be -6 but have a difference of just 1. 3 and 2, where the 3 is what? Positive or negative? Positive, because my first term or my second term is positive. All right, so I got x plus 3, x minus 2. Final part of this, how do I solve for x? Set the individual factors equal to 0, so x plus 3 equals 0, x minus 2 equals 0. What does x equal? -3, or what do I do over here with the x minus 2 equals 0? Add 2. Okay, so x equals -3 or 2. All right. Can it be both of those things? Is there one I should pick over the other, and why? -3 or 2 both solve the quadratic equation, but we're dealing with a real-world scenario here, right? Meaning that I have a rectangle that I have to think about. Do both of those numbers work? No. See, 2 times -3 is -6. -6 plus 2 is what? Is -4. 7 is, yeah, so can I have a length that's -4? So I can't have x be -3. Okay? So if we're looking for the individual lengths, I should go with 2. 2 times 2 is 4 plus 2 is 6. Okay? So I should get 6 for the length, and 7 times 2 is 14. 6 times 14 should have an area of 84, right? All right, and that is inches and inches here and here. Okay, now I didn't write that up in a 2-column proof, but I did try to give you the justification for the steps as we went along. Okay, you shouldn't see anything that's quite that long. You do have, I believe, some proof questions on the test, but the proof questions on the test are nothing like that. Proof questions on the test are going to have the proof already done up for you, but it's going to have blanks in it that you need to fill in, and they're not terribly hard, okay? All right, so that was 16. Let's take a look at 7. 7. Okay, this one is also in video 1. Okay, so we don't need to look at that. Let's take a look at 13. 13. Okay. So 13 says in circle A, AE is 6 inches. Okay, so this here is 6. BE, okay, BE is 8 inches. AB is 10 inches. BAC, okay, BAC, so that's this angle right here, is 53 degrees. And DAC, okay, DAC, so that's this outside angle here, is 110 degrees. Okay. Okay. It says, is triangle ABE a right triangle? Explain how you know. Okay, is triangle ABE a right triangle? Explain how you know. Is it a right triangle? It is. How do we know? Because it looks like one? I don't know. We could go based upon that. So if we said that 6 squared plus 8 squared equaled 10 squared, right? We have a triangle. Okay, we got 36 plus 64 should equal 100 if it's a right triangle. 100 equals 100. Okay, and all of this is going to that right there. So yeah, it's a right triangle because the triangle is a Pythagorean triple. Okay? Or it, I would say through the converse of the Pythagorean theorem, right? Okay, so yeah, it's a right triangle. It says find the circumference of circle A to the nearest tenth. Use 3.14 for pi. Okay, so what do we have to have in order to find the circumference? Diameter or radius. Is there a line up there that represents the diameter or radius? What is it? What line represents the diameter or radius? AC. AC does represent the radius, but do I know the length of AC? No, I don't. Is there another line that represents the radius? A what? AE? Can you define what the radius is for me, Christian? Half the diameter, but more specifically, it's a line that goes from the center all the way to the outside edge, right? Okay? AE only goes here to here. Do we see that? So AC, like we've said, is a radius, but not AE. What other line is a radius? DB? No, well, DB would be a diameter. AB. All right, and the reason I say AB, why is AB so handy? Because we already know the length of it, right? So we know that the radius is 10, okay? Because AC is an unknown, but AB is a known, right? We were given that information. They told me that the center of the circle is A and how they labeled it. B is obviously on the outside edge. Okay, so we know that the radius is 10, correct? All right, so 2 pi 10 or 20 pi, okay, or 20 times 3.14 would give me my circumference, right? 20 times 3.14, 62.8. Okay, so circumference for B, 62.8, and this is inches, right? Just inches, because we're talking about a solid, just straight length. Okay? Do we understand that? Sometimes in these questions, it's knowing where to look. All right, C, find the area. Well, we already know the radius is what? 10. All right, how do I find area? A circle. Okay, pi r squared. All right, I know there's not that many people in the room, but we're leaning really heavy on Riley to answer these questions for us, okay? You need to try to push yourself, or I'm going to start, calling on people, and I'll just wait. We've got time. All right, so pi, Jewel, what was the radius again? 10. So pi 10 squared. Okay, we're using 3.14 for pi. Can you tell me what the area comes out to? Pi times, not just pi times 10, but pi times 10 squared, pi r squared. If our radius is 10, pi r squared, but they want you to use 3.14 for pi. $314. And because it's area, we know that we're working with inches, so it should be inches what? Squared. So 314 inches squared is our area. Okay? What is the measure of BD? Okay, what is the measure of BD? Okay. I'm going to erase some things up here. What is the measure of arc BD? Okay. So we have somewhat of a problem. Okay. Is BD a diameter? No. How do you know it's not a diameter? It's angled. It doesn't really look like it, but if that was a straight line, right, they tell me the angle BAC is 53 degrees, but DAC is 110. If that was a straight line, if BAD was a straight line, what should it add up to? 180. And it only adds up to what, 163 degrees, correct? All right, so BAD is not a straight line, so be careful with that. Okay, but we want to find the arc BD. So the reason I say be careful with that is because if it was a straight line, we would know that the arc would be 180 degrees, right? What is that arc? Well, A's at the center, right? Okay. So we're working with a central angle of what? What's the center angle that intercepts arc BD? We're looking for an angle which should have 3 letters. What's the angle at the center of arc BD? ACD, AE. Okay, look. BD. Okay, we need an angle that happens in the middle of that circle that has endpoints B and D. What's the, okay, say it again. A, BAD, right? So, because A is in the center, if I know what this is, then I know what this is, correct? All right, which is why we established at the beginning. In fact, the answer is a number that I just put up there not very long ago. What is it? 163 degrees, okay? That 53 plus the 110. That's the reason I told you, make sure that you see that it's not 180. Don't assume it's 180 in the center, therefore the outside is 180. If you remember, I think it was on our last test or a couple of tests ago, where you had something that looked like that roughly, okay? And it said this is 93 degrees. You know, let's say this is AC, and it says, what is arc AC, right? Well, what is arc AC? 93 degrees, okay? You know, this is going to be the same as that, okay? Or vice versa. If I ever know what arc AC is, I should be able to find out what the central angle is, okay? So long as it's a central angle, they'll be the same. Okay, there's no real math to do except in this case of adding 2 numbers that make up that central angle. Does that make sense, or does that seem over the top? Okay. All right. Use the arc addition postulate to justify your answer. It's just arc 53 plus arc 110 be the same thing. All right, so that's 13. Let's look at question 15. It's the same, it's the exact same thing as your rectangle question. Do we want to see it again? Okay. Yes, no? Anybody in here need to see it again? Okay. All right, so that's covered several questions. So if you end up watching both videos, you'll see some of the questions that you guys had. All right, from here, let's go to, if I can find it, I believe it's over here. I'm going to take you back a couple questions, okay? Just because there was no sound the first time through, or I don't know how much sound there was. All right, what you see right here and above is what the question says. It says, what is the maximum area, and I know my handwriting is abysmal, but I try to get through as much as I can. What is the maximum area of a rectangle that has a perimeter of 168 feet? And what I showed them is that, hold on, this should say well, let me double check. 168, what's that one? Yeah, okay. So we could create all kinds of different rectangles that have a perimeter of 168 feet, right? So I showed them, for instance, like what if we had a width that was only 2 feet? What would the length have to be to create a rectangle that's 168 feet? Well, we would subtract 4 from 168, right? We would get 164. 164 divided by 2 to get the length, we'd get 82 and 82. We would find that we get an area of 164 square feet, okay? Now, if we make it a little bit wider, not even a lot wider, but if we take it to 10 and 10, right, that gives me width of 10 feet and 10 feet, so there's 20 feet. Subtract 20 feet from 168, which leaves you with like 148, okay, something like that, which would give you lengths of 74 and 74. And if you find an area of that, you see that it goes from 164 to 740, okay? So as I shortened the length and I added to the width, notice that the area got bigger, okay? And what we should learn from this is if we continue to add to the width and subtract from the length until those numbers get closer and closer to actually being each other, right? The bigger and bigger our area gets, even though our perimeter stays exactly the same. So this actually has a really good practical application in that, let's say that you have a farm and you can only afford so much fence and you want to fence in some calves, okay? Well, you want them to have the largest area available for that, for the amount of fencing that you have. So the closer that your area gets to being a square, right, the more area it has, or the more your perimeter gets to being a square, okay, the greater the area. So we take 168 and divide it by 4, and that assures that I'm going to get sides that are all the same length. And then if I take my length times my width, right, I find out what my area would be for that perimeter. Does that make sense? Okay, so if I take 168 and divide it by 4, that gives me 42, which shows me that each side is 42. To find the area, I take 42 times 42, and I get 1,764 feet squared. Is that bigger than 164 feet squared? Right. Okay, considerably. So that shows you what kind of impact a shape like a square has on an area versus just any kind of rectangle. Does all that make sense? Great. All right, question number 2. They're going to tell you that you have two triangles. One is ABC, one is XYZ. BC is 30, AC is 40, AB is 20, YZ is 40, XZ is 20, XY is 30. And that is basically the extent of what the question is going to tell you. They're just going to say, write a congruency statement for that. And so the mistake that most people make with a question like this is they automatically assume if it's triangle ABC, it's congruent to triangle XYZ. Okay? But before we know for sure, we actually have to draw it. Okay? What we get when we draw it is something that looks like this. And what this question is asking you to do is, can you see what corresponds to what? Okay? Notice that A is between 20 and 40. X is between 30 and 20. Does A correspond to X? No. Okay, what does A actually correspond to? Well, what else is between 20 and 40 on the other side? Z, okay? So it doesn't have to be oriented the same way. It just has to be between the same two numbers, okay? So then you go to B, because all of them will start with triangle ABC. So your job is to find out what corresponds to A, what corresponds to B, what corresponds to C. Does that make sense? So as you go to B, you see B is between 20 and 30. So what's between 20 and 30 on the other? What letter? What letter is between 20 and 30 on the blue triangle? No, between 20 and 30. What is between 20 and 30? X. Okay? Then I get to C. What is C in between? 40 and 30, right? Or 30 and 40. What is between 30 and 40 over here? All right. Well, I'm hearing right answers and I'm hearing wrong answers. Christian, what is between 30 and 40? Z? Z is between 30 and 40. So this angle right here is between these two things. All right. Do you understand what I mean by in between? Okay. So what's between 30 and 40? Y is. Okay? So, here's your 2040. So here's 2040. Okay? 2030. Okay, is there. 2030 right here. 30, 40. 30, 40. Okay, does that work? Is that easier to see? Okay, because it's not, you're not going to get anything below this red line. You're going to have to do all of that. All right. All right, question number 3. Let's see. Again, they're not going to give you anything below that red line. The question is what you see above. A major arc of 4x plus 80 degrees has a corresponding minor arc which has a measure of 3x minus 60 degrees. Find x. So what you need to understand is that a major arc plus a minor arc equals a whole circle. How many degrees are in a whole circle? 360. Okay. So I need to set those two arcs equal, add them up and set them equal to 360, solve for x. Okay, and all this question is asking you to do is just simply solve for x. But if they ask you to solve for the major arc and the minor arc, we should be able to substitute back in. Okay? So 4x plus 80 plus 3x minus 60 equals 360. Combine your like terms, solve for x. I think we can do that. Okay? All right, let's try to move forward here a little bit. If I can pull up that question. Okay, 4. Now, this is a good question because I felt like we kind of struggled with this on question number 2 a little bit. So they're going to give you, you know, kind of an obscure figure. Okay, something like this. And they're going to say, what is the, what's this? Included angle of, let's see, AB and let's do this. Change it up a little bit here. Let's say DC and BC. What's the included angle of DC and BC? What is the included angle of DC and BC? Okay, so I've got one angle A. Okay, anybody else? Thoughts? Okay. All right, let me just do this. I'm going to highlight line segment BC and line segment DC. What is the included angle? It's not A. BAD would still be angle A. BAD is still angle A. It can't be angle A. No. Here's what you guys are missing. The included angle, you could replace the word included with in between. What angle is in between side BC and side DC? C. Okay, it is the included angle. Does that make sense? So the same thing that we saw back here, right? What we're talking about here is what is the included angle between 20 and 40? Well, that's angle A and that's angle Z, right? That's the included, we want to have the same included angle, right? The included angle between 20 and 30 on both of those is B and X. It's included, it's in between. Does that make sense? All right. I'm not trying to be belittling at all, right? I just want to make sure that we have the best test we can possibly have, okay? And that we don't even have to worry about retakes. All right. So looking at this, what if the question were, what is the included angle of let's say DC and AD. DC and AD, what's the included angle? D. In fact, what you should look for whenever they say the included angle between two sides is what letter do both sides have? Okay? So you hear DC, CD, D shows up in both. D is the included angle. Okay? Any other questions on that? Okay? All right. This next one is a little tougher. We need to determine if this next statement is going to be true by the law of syllogism. Okay, the law of syllogism. Okay, how many things, can anybody give me an example of what I might look for when talking about the law of syllogism? There's actually a property that we work with on a much simpler scale that the law of syllogism is based on. You know how many variables we work with when we talk about the law of syllogism? Okay, if Q, then R. Okay, then, or sorry, then we would have like if what? If R. Okay, good. If R, then S, and then finally, therefore, if Q, then S. Perfect. That's exactly what we're looking for. We're looking for three things, right? It is basically if A equals B and B equals C, then A equals C, right? It's equivalent to that, okay? So that's what we're trying to determine based upon this. Let me write down kind of their example. If you are in Missouri, okay, if you're in Missouri, then you're in what? If you're in Missouri, then you're in the Midwest. Okay. Okay. If you are in, oh, what's a town that's only in Missouri as far as we know? Green City. If you're in Green City, okay, then you are in Missouri. There might be green cities in other states, but we're not going to worry about that, okay? Let's see. Let's get our last part of it here. Okay, then we would have our conjecture. Our conjecture would be, okay, therefore what? What would our conjecture be here then? Therefore, if you are in Green City, then you are what? What's the last thing? Then you're what? Then you're in the Midwest. Very good. Okay, and we should be able to look at this and say, you know, Missouri is P, right? Midwest is what? Can we say Q? Or you could say AB. What is Green City in this? Can we say R? PQR? Okay. And then it goes back to Green City, Missouri. Well, okay. So what we have first is we have P equals Q, right? From our first statement. And then what? R equals what? R equals P. Did we say what? Nobody's. All right, look, if you're in Missouri P, then you are in the Midwest Q, just so that we see what is what. Okay, so P equals Q. Next statement, if you're in Green City, that's something new. R, what does R equal? R equals P, okay? Right, when we get down here, right, what is Green City? No, look, we've already labeled it. R, and what is the Midwest? Q. All right. Does that connect everything to everything else? We got P to Q. We got P to R. Okay. We've got Q to P. We've got Q to R. We've got R to P. We've got R to Q. Is everything connected? Yes. Okay. So we would say, yes, our conjecture is valid. Does that make sense? Okay. Oh, let's see. What time are we out of here? 57, 58. Okay. Number 6 also uses the law of syllogism. Do we feel like we need to cover another one? Now, that one was kind of using locations in geography. The next one will use math. But the same principle applies. If I go through there and I underline the principal part, right, there should be 2 parts to each sentence. If this, then this. All right? The first one I'm going to label, I don't care if you use A, B, C, X, Y, Z, P, Q, R. It doesn't matter. So long as you underline that portion so you see I'm connecting this thing to this thing. Then the next sentence, I'm connecting this thing to this other thing. Therefore, in the end, if I'm connecting this, all right, I need to connect it to something it hasn't been connected to yet. Does that make sense? All right. If we have to, I'll probably cover number 6 with first period tomorrow. Okay, but hopefully you guys have a good understanding of the law of syllogism at this point. Does that make sense? All right, so you're not actually doing math. All you're doing is connecting something that what it hasn't been connected to yet. Okay? I think you saw a question like that where the answer was like right angles. Right? It didn't matter that there were other true statements. Right? What we were looking for is the thing that it needed to be connected to. All right, I'll stop there.